This is problem 17 from chapter 17 of the textbook Stats Modeling the World, 2nd edition. Okay, so here, this is problem 17 is actually a continuation of problem 13 with some differences. In problem 13 we were looking for left-handers. Now it looks like we're looking for right-handers. And instead of choosing 5 people at random, we're going to choose 12. So we have a few things that are different. The sample size is 12, and now the probability of success, we're just going to kind of flip things. The probability of success is going to be 0.87, and the probability of failure is going to be 0.13, because remember, 13% were lefties. If you recall, go back up here. Here's the information we were given. So we have a Bernoulli situation. We have success failure. 20%, 20 people is still 10% of all people. So it's safe to proceed with a Bernoulli situation. Okay, so here we're asked find the mean and standard deviation of the number of right-handers in the group. So this kind of implies we're still interested in the number of successes in n trials. So that implies binomial. Okay, so there we know that mu equals, and I'm not sure if we could just let x be the number, let x be the number of right-handers discovered. Okay, so my notation here, this would be the expected value of x. So that's just going to be NP. So it's going to be 12 times 0.87. And let's see, that's going to be 10.44. Right-handers. Righties. Okay, now the standard deviation is going to be the square root of NPQ. So that's just going to be the square root of 12 times the probability of success times the probability of failure. And that comes to 1.16 righties. Okay, so now we're asked, what's the probability that they're not all righties? Okay, so let's think about this. I'm going to have to think there's a couple ways of doing it. One is a tree, but another way is to sort of do a probability model. Probability of x. Now it's going to be hard to go all the way out to 12, but let's see, let's at least get started. So 0, 1, 2, like that, and then we go out to towards the end of the model, it's going to be like 11 and 12. So x would be the probability of getting a righty, and so what's the probability that they're not all righties? So I think it would be all of these, right? So could be 0 righties, but we just want to avoid 12. So there's a couple ways of doing this. We can say probability of not all righties is equal to, so we could just do binom CDF of, so n is 12, probability of success is 0.87, and then just give it 11. And that should do it. So that would be 0.812. Okay, another way would be to say, well, it's 1 minus the probability of 12. So you could do 1 minus binom PDF of 12.8, why did I say 0.2? 0.87, comma, just 12. So it would give you this probability, and you'd subtract that from 1, and you'd get all the others. And that's definitely what you would do if you were going to use the notation, the formula. You would say minus, and let's see, n is 12, and you would say 12 here, like that, and then you would do probability of 0.87 to the x is 12, and then this would be 0.13 to the x minus n, so that would be 0. Okay, and in all these cases you get 0.812. 0.812. Okay, so there's actually 3 different ways to do that problem. Okay, what's the probability that there are no more than 10? Alright, so let's draw this picture again. P of x, and then we've got 0 and 1, and then I'm just going to start here and go out, and then let's just go out to say 9, 10, 11, and 12. Just going to try to draw a little picture so I can sort of connect the words. Think of it as, I'm just taking a shortcut here. Okay, what's the probability that there are no more than 10? So it would be all of these. So that's the probability that x is less than or equal to 10. So for me, that's just binom CDF of 12. Probability of success is 0.87, and we want to include 10, so we say 10. No more than 10, so 10 works. Okay, and so that comes to 0.475. Okay, I think we need to do one more. No, 2 more, my bad. What's the probability that they're exactly 6? Oh, well, that's pretty easy. The probability of exactly 6, x equals 6. So now we're just going to use PDF. So that's the probability of binom PDF. And we're going to just say 12.876. If we were using the formula, it would be 12, 6, and it would be 0.87 to the 6, and then it would be 0.13 to the n minus 6, so 12 minus 6 is 6. Pretty sure. Yeah. Okay, so that's going to be 0.00193. Okay, last one. What's the probability that the majority is right-handed? Okay, so now they're really messing with it. So what would a majority be considered? Well, let's see, there's 12, so half of 12 is 6. So a majority would, I think a majority would be x greater than or equal to 7. Okay, so that's the probability. If it's the probability of x greater than or equal to 7, then that can include the probability of x equals 7 plus the probability of x equals 8 all the way out to the probability of x equals 12. Okay, so what we want to do, maybe I can just do this one more time. X, P of x. Let's just, I don't want to quite do that. We're interested in 7, so let's just do sort of like 6, 7, 8, out to 12, and over here it's 0. So we got 0, 1, and then we're going to go sort of dot, dot, dot. So you can kind of see the probability model. So we want from 7 on. We want to add up all these probabilities. So the calculator only takes, the CDF only works to the left. So we could say this is going to be equal to 1 minus the probability of x less than or equal to 6. So that's going to be 1 minus binom CDF of 12.87 and 6. And that's going to equal 0.998. Okay, so I hope that helps. That's quite a bit, but kind of shows you the techniques, and of course you have a couple options. You might even be able to try using a tree, but with n equals 12, a tree is kind of complicated. So anyway, good luck.